anybody remember any of them? Angle pairs, so we have to have two, at least two angles. So we have complementary, good. Supplementary. What else? Just two more. Okay, pairs of angles. Vertical. Gosh. One more. Similar to supplementary angles.
Oh, linear.
Linear pair, good. Good. So, we just need to know what all four of those angles are. So, if we have complementary angles, what are complementary angles?
90.
John, you writing this stuff down? Complementary angles. They are what? They add up to 90. Two angles add up to 90 degrees. Do they have to be connected? No, they don't need to be. What about supplementary angles then? They add up to 180. Do they have to be connected or touching? No. Now, linear pair. What's a linear pair? This is the one you guys struggled with. John?
They add up to 180, but they have to be touching.
Perfect. They add up to 180, and they have to be touching. So linear pairs will always look like that. They're on that line, but they have to be touching. So these two are a linear pair. Okay? They have to be touching. That's the difference between supplementary and a linear pair. Supplementary don't have to be, but they're still adding up to 180. Then vertical angles are what? At angle 1, 2, 3, 4. Which ones are vertical? So which numbers? 2 and 4 and 1 and 3. Okay? We need to know these four because we're going to use these with theorems. So that should just be a quick review, right? We're remembering it. It's coming back to mind, right? Okay. So we have four theorems that we need to write down. They're also on page 124, so if you ever need a more in-depth description, you can go there, okay? But we need to write all four of these down. Leave just like a line in between, because I'm just going to write an example for each. But in the homework, you're going to use these theorems in the reasons, so you need to know what they are and what the names are of them. And once again, in the reasons, you can abbreviate like RT. You can even write that symbol, congruence theorem. Theorems abbreviations are always THN. So that's an example of how you can write it and if we use them in the reasons part. Now, right angles congruence theorem is going to seem silly. It's going to seem redundant. All this is saying is that all right angles are congruent. Makes sense, right? Seems crazy that we need to have a theorem to tell us that every right angle is congruent. But by having this theorem in proofs, it helps us from going through numerous steps. It allows us just to write one step. So this literally just says that all right angles are congruent. Now we have congruent supplements theorem. What did we say supplementary angles were? They add up to 180, right? So this tells me if I have, let's say this is angle 2, and we're going to say it measures 140 degrees. And we have angle 1, it measures 40 degrees. We agree those two are supplementary. Right? They add up to 180 degrees. So angle 1, angle 2 are supplementary. Now, if I had another angle, let's say angle 3, if I told you that angle 2 and angle 3 are supplementary, what does the measure of angle 3 have to be? 40. How'd you get 40?
Took 180 and subtracted
Right, because if we know that this angle and that angle are supplementary, they have to add to 180, right? So we know that this is going to be 40 degrees. So we know if we have these two supplementary angles and then 3 and 2 are supplementary, this theorem tells us that angle 1, it will be congruent to angle 3. And that's true, right? They're both 40 degrees, so the angles are congruent. This theorem tells us if we have two angles and they share the same supplementary angle, those two angles will always be congruent. So do you guys want me to write something in words? Will that help you? Okay. So if we have, if two angles share the same, I'm going to abbreviate, supplementary angle, then those two angles are congruent. Does that make sense in words?
Yes.
So I try to draw a picture and words so that you can actually see it. It makes sense, right? Because they're sharing that same 140 degree angle, so both those are going to have to be the same. Now, if that's the congruent supplement, what do you think the congruent complement is going to be? Right, it's going to be the exact same, except they're going to share the same complementary angle. So instead of adding to 180, they're going to add to 90. So, I'll write in words. If two angles share the same complementary angle, then they are congruent. Once again, makes sense, right? Because they're going to share that same measure of that angle, so they're going to have to be congruent. They're pretty self-explanatory, but these theorems help us in proofs. We can put that as reasons instead of going through all these proofs. There are proofs for each one of these theorems in the book that if you don't believe or you want to look at them. Okay? Now, a lot of you might have known this one, but now we have a theorem for it. So we talked about vertical angles being what? Directly across from each other? So if here's angle 1, 2, 3, 4. We said which angles were vertical? 2 and 4, 1 and 3. Now, the vertical angles congruence theorem. Anybody have any idea what it's going to tell us? Read the name. What do you think?
Vertical angles are congruent.
Perfect. This theorem tells us that all vertical angles are congruent. And when we were going through all these vertical angles, I remember somebody talking about, well, these are congruent. So did you guys know this already? Did anybody have any idea of this? I heard it a couple times throughout the classes. But this theorem tells us all vertical angles are congruent. And they might have looked like it, but now we know that they are congruent. So, angle 2 measured 40 degrees. What would the measure of angle 4 be? 40 degrees. Right? The measures will be the same. And I said all of these three have proofs. We're not going through them, but we're going to go through this vertical angle one. We're going to do a proof with this to show how and why they're congruent. Okay? Is everybody good with these? Remember, they're also on page 124, so if you want in-depth descriptions, feel free to look there if you're having troubles with them. One last new thing is a new postulate. It's called the linear pair postulate. Remember, this is another pair and we haven't talked about them yet. What are the two named postulates that we have to remember? Segment addition postulate and angle addition postulate. Those are the only two named postulates that we need to remember. We don't need all those numbered postulates. We don't got to remember them. Now we have one more postulate we need to remember. Linear pair postulate. We already knew this postulate, but this is the actual postulate. It's saying that if angle 1 and angle 2 form a linear pair, then angle 1 and angle 2 are supplementary angles and they add up to 180. We already knew that, right? Hadn't we already figured that out?
Yeah.
So we knew that, but this, instead of going through proofs saying, well, this because it's supplementary, then this because linear pair, now we can just use linear pair postulate because it tells us linear pairs add up to 180. So to prove that vertical angle theorem, we're going to use that postulate in it because there's a bunch of linear pairs. So the last thing we're going to do today is prove that theorem. And this will help you proofs too because we're working on proofs. So we got to see how all these proofs are laid out. Is everybody good with that postulate? This is also in the book, so if you need in-depth definitions, we sure can. So we're going to prove that vertical angles congruence theorem. And I'm going to label my lines, my angles. Vertical angles congruence theorem tells us what? What does that theorem say? Vertical angles are congruent, correct? Everybody agree?
Yeah.
So we need to prove that those are congruent. Angle 1 and 2 are congruent. So where do we start? We know that angle 1 and angle 2 are vertical angles. Okay? That's given. Remember, you can abbreviate, use that angle symbol. And our reason for that first part is what? What's our reason for number 1?
Given.
Given. Right? That's always given. Now, before I said we're going to use that linear pair postulate in this. So hint, linear pairs. Is there anything, do I have any linear pairs over here?
Yeah.
Which ones?
1 and 3, 2 and 3.
Angle 1 and what?
1 and 3,
Angle 1 and 3 and angle what?
2 and 3.
Both of these are linear pairs. Why? How do we know that they're a linear pair? Right. What does a linear pair tell us? They're on the same line. So we literally just use the definition of a linear pair. Now, we want to use that linear pair postulate. What did that postulate tell us? If they're linear pairs, what do we know about them? They add up to 180, right? They're supplementary. So we also know that angle 1 and angle 3, angle 2 and angle 3 are supplementary by that linear pair postulate. So what told us that if these two are supplementary and these two are supplementary, these are congruent. What was that theorem that told us that? What was it?
Yeah. To the bottom. Okay, thank you.
Congruent supplement theorem. Okay, so these are going to be like some of those proofs on that homework page 128. So write down that homework. Tomorrow we're going to work on combination of all